So before beginning, I have to admit something that, so my nature is sort of to be a devil's advocate. And so in front of this gathering of Wi-Fi experts and Keith and Devin, I'm here to proclaim that 2.4 is not dead. So the guys in the back, can you read this? Okay. Okay. I was just kidding. I need to begin with sort of an apology because the title of the talk was to discuss the Touchtone mobile app that it's a spectrum analyzer app that we hoped was going to run on the Android tablets that we all receive. But as Keith mentioned earlier, because it doesn't support OTG, which I'll discuss a little bit later, I sort of had to change gears. And instead, I've modified the talk to be a little bit more generic. And it's going to be more about why we feel that the Android platform is going to be the platform of choice for developers and companies to develop diagnostic tools to troubleshoot Wi-Fi and RF. So I want to talk a little bit about why we think Android is going to be a good platform for that. And yep. So my name is Steve Leytus. I'm from Nuts About Nets. And our company, we develop low-cost diagnostic tools for troubleshooting Wi-Fi and wireless communications. And the focus, we have two focuses. The apps, the diagnostic tools, troubleshoot Wi-Fi, and the other one is wireless pro audio. And it turns out that that both in Wi-Fi and wireless pro audio, you can use the same tools because they're trying to solve the same type of problem. And even though they operate in different bands, they both, in the end, are always trying to find the best channel. And in particular, our focus is RF interference. It turns out that both in Wi-Fi and wireless pro audio, RF interference is responsible for the majority of the problems that we run into. And if you were to speak to any technician whose job it is to troubleshoot Wi-Fi, or if you speak with an audio engineer, the way that they solve most of their problems is to choose a different channel. So our focus is developing diagnostic tools and troubleshooting wireless applications. And the focus is on RF interference. So the app that I wanted to talk about today is called Touchtone Mobile. It's an Android app, and it's a spectrum analyzer app. And we have a Windows version called Touchtone Pro, and both the mobile version and the desktop version use a handheld spectrum analyzer called RF Explorer. And this is a remarkable device. It's been out for a couple of years. Our company, in addition to developing software, we're the major distributor for RF Explorer in the US. And what makes it a compelling device is first of all, its cost. There's several different models. They run between like $129 and $350. And if you've been around RF spectrum analyzers for a while, some of you may remember these big devices weigh about 50 pounds or whatever, cost tens of thousands of dollars. So this is a true spectrum analyzer. It's not a research grade or laboratory grade one, but for many RF applications, it does a great job. And so we use it for for measuring RF interference. So let me switch gears and tell you a little bit why we think Android is going to be the platform of choice for developing diagnostic tools. So about 3 years ago, we developed our first Android app, and it was about a year ago, we decided to jump on the bandwagon and really focus on Android because going forward, there's many advantages for developers to use to develop software for Android. So, so the three things I've mentioned here is that, so Android is very inexpensive. You can go to like a Best Buy or online, and you can buy an Android tablet for like less than 40 bucks, and which is quite amazing. And the other thing is that it also supports a technology called OTG, and I'll mention a little bit more about that. And the other thing is that it's basically an open platform. Google supplies good development tools, so if you're interested in developing an Android app, they make it easier. Apple, there's more hoops you have to jump through. So regarding the Android device, in addition to being inexpensive, what you get is a decent CPU, you get memory, you get a nice display screen, you get a rechargeable lithium battery, and you even get a Wi-Fi chip. And when you think about it, what that allows the developer to do is that now you can focus on the device that you want to attach to that's going to attach to the Android. If you build, I mean, some of these other proprietary handheld tools are expensive because all that functionality is also built into the handheld device. But because Android basically gives that to you for free, when you develop a new tool, you don't have to worry about all that stuff. You can focus just on the sensor or just on the tool that's going to collect the data. And it makes a big difference in terms of what it costs to develop the tool, how long it takes you to do it, and so it makes it sort of a no-brainer to, if you can take advantage of the Android device to develop a tool that uses Android. And so a little bit more about OTG. So OTG stands for on the go, and OTG is a USB standard. It's hardware. Either your device supports it or it doesn't. It's part of the USB chip that's built into the device. USB host mode is more of a software thing. It's something that the operating system has to support. And these days, the latest versions of Android support USB host mode. It's something that Google feels is a critical feature. So going forward, most Android devices will support USB host mode. Not all hardware vendors support OTG, and it's a matter of cost. But because Google thinks that USB host mode is so important that the most recent Android devices will support OTG. And on this slide here, I just wanted to show that in USB host mode, there's this concept of a host and a peripheral. In this case, the Android device is considered the host. The things that you attach to it are the peripherals. And the way that you connect them is you use this USB OTG cable. It's not a standard USB cable. It's called an OTG cable. And that's how you connect the host device, in this case Android, to to one of the peripherals. And the peripheral that we're most interested in is the RF Explorer device. Okay, so on this slide here, I've taken some liberty, and I refer to this as an OTG stack. It's not a stack in the sense of like a network stack, but when you're trying to develop an application for USB host mode, you sort of need a way to envision how all these pieces sort of fit together. So down at the bottom is a peripheral, the RF Explorer Spectrum Analyzer, and it has a USB connector and a USB chip, and it's the most common ones are manufactured by Silicon Labs or FTDI. So, but it has a USB connection, and the way that you connect it to an Android device is through an OTG cable, and the Android OS has to know the way that it talks to the OTG chip in the device is it has a device driver. And so I wanted to show here that the Android OS talks, it provides the driver to talk to the OTG chip. And then at the next level up, you need like a USB library, and what it does, it hides all the details of using at the very top we have the application, and when you write it, it's usually written in Java, and you write to the OTG chip using a serial protocol, and there's a USB library that sits in between that allows you, that makes the transition from serial to USB. So when you write the application that talks to the peripheral, actually you write it as if you're writing a serial application. Okay. Okay, so here, I just want to show you, this is the final product. This is touch-tone mobile running on an Android device connected to an RF Explorer, connected with an OTG cable. This is, you can see the spectrum trace. Again, it's low cost, it's mobile, it's true spectrum analysis. And again, the app has a number of different graphic charts, spectrum trace. It has a density chart, also called a topographic chart, and it displays the signal at specific frequency. It shows how often the signal is detected at a specific frequency and amplitude. And the advantage of using the density chart is that whereas with spectrum trace, you oftentimes don't see anything because the trace is so fast, but with the density one, patterns start to emerge that you otherwise wouldn't see. And there's another one called monitored frequencies that's usually used for the Wireless Pro audio crowd. And these are just the minimum requirements for OTG to work. And like I said, like over 90% of Android devices support or are running OS version 4.1. And I guess I sort of wanted to finish. This is another Android app. It's called Wi-Fi Explorer. This one does run on your tablets. Wi-Fi Explorer, it's a network discovery app. It definitely supports 2.4, and we happen just to include 5 gigahertz for those guys who feel that 5 gigahertz is important. And I want to end with a little historical perspective. This is the first Android phone. So thank you.